What is an algorithm? Algorithms are one of the most basic building blocks of computer software. Every piece of software you interact with, from your smartphone to your web browser to your coffee maker, uses an algorithm somewhere. So, what is an algorithm? An algorithm is a set of step by step instructions that is used to do something. With a definition that broad, it's not surprising that they are in everything. It might surprise you that you yourself probably use algorithms in your day to day life, even if you don't call it that. If you sort your laundry before washing, first let me say good for you. Second, you probably do it following an algorithm. Take a piece of clothing. If it's white, put it in the left pile. If it's colored, put it in the right pile. Repeat until you're done. That's an algorithm. The power of algorithms comes from the fact that computers can follow these steps quickly and very precisely. For example, how do you look up a name in the phone book? If you're like me, you plop the book open somewhere. If you've gone too far, open a spot closer to the front. Otherwise, move toward the back. When I feel like I'm close, I start going page by page, looking at the first or last name to know if I've gone too far. Computers can do better. A phone book is essentially just a sorted list of names. If you have 1,000 pages in the phone book, you can use an algorithm called binary search to require at most 10 page turns. It works like this. Say that you're looking for Jill Jackson. Start in the middle at page 500. The first name on this page is McDonald, so we've gone too far. We know the M in McDonald has to be after the J in Jackson, so the right page is before page 500. Divide the pages in two again and turn to page 250. This time the first name on the page is Flores. Now we've gone too far to the front. There are 250 pages left, so we divide by 2 and turn to page 375. We repeat this process until we find Jill Jackson, which will be at most 10 turns. This might be difficult for you or me, doing math on the fly and turning directly to the right page, but a computer has no problems with this. And an algorithm like this is efficient in terms of the computer's processor, meaning it scales amazingly well. This process takes 10 steps in a 1,000 page phone book. If we switch to a phone book with 100 million pages, it would still only take 27 steps. Algorithms can also do more complicated things. PageRank, the algorithm underlying Google search results, is one example. There are lots of pages on the internet that talk about cheese. If you search for the word cheese, which results would you expect to get and how would they be ordered? A naive approach might be to rank most highly the page with the most occurrences of the word cheese. Unfortunately, that breaks down pretty quickly when you think about a very long page with just the word cheese repeated over and over. While it might have the most occurrences of the word cheese, it probably isn't the page you want. So how does Google do it? In the early days, at least, they used an algorithm called PageRank. They start the algorithm by crawling every page on the internet and keeping track of what other websites link back to that page. The logic goes that an important page will have many more links pointing at it from other pages than an unimportant page will. Each link is also scored, with links from other important pages being worth more than lesser links. The logic behind that decision is that if your page is linked to by whitehouse.gov, Wikipedia, and the New York Times, those three should be worth more than links from your 10 best friends websites. At the beginning of the algorithm, each page is given a starting value of 0.25. As new pages and links are explored, the score for each page is updated. A link to a page confers that page's own value divided by the number of links on the page. In other words, if a page has a value of 0.25 and only has one link, that link will add 0.25 to the page it links to. If it has 5 links, each of those links is worth 0.05, 1/5 of the original value. After crawling the entire web, each page ends up with a score ranking its importance. When you search for a phrase, you are given a set of results based on the content of each page, does it match your query, as well as the page's importance, does Google give it a high PageRank value. Google's system has evolved and become more sophisticated, but PageRank remains a defining algorithm of the web. Algorithms underlie all the code running everyday things like the internet to the most sophisticated machine learning projects in the world. Underneath the covers, they are really just following a set of instructions, an algorithm.